Page 17. You guys have this packet? Okay. Okay, Pythagorean theorem problem. Two cyclists leave from the same position. Cyclist A travels north 10 miles per hour. One hour later, cyclist B leaves from the position and travels due east 20 miles per hour. At what rate is the distance between the two cyclists changing 2 hours after cyclist B leaves? Pythagorean theorem. Here's the derivative. Morning. Morning. Okay, list out all your variables. Okay, so cyclist A travels north at 10 miles per hour. North doesn't guarantee that the rate is positive, but here the side of this triangle is increasing over time, so we want this to be a positive 10. Cyclist B, east 20 miles per hour. Positive as well, because this side of the triangle is also increasing. At what rate is distance between them changing? That's dz/dt. So cyclist A, north at 10 miles per hour. 1 hour later, he's gonna cover 10 miles already, right? But then this is 2 hours after cyclist B leaves. So we have to add on another 2 hours. So how much more distance did cyclist A travel? Plus what? $20, right? So we can imagine this 1 hour, he's 10 miles up. 2 hours later, he covers another 10 miles, another 10 miles. So that's 30 miles. Okay, does that make sense? Okay. So 2 hours after cyclist B leaves, cyclist B is going to leave. So that means 20 miles, 20 miles, no, 40 miles. Because he's traveling at 20 miles per hour for 2 miles, for over 2 hours. Okay, any questions about how we got these X and Y's? Okay, to solve for Z, use Pythagorean theorem. This is a variation of 3, 4, 5 triangle, so plug everything in. We solve for dc dt. Okay, any questions? Number 1. And we're on page 17. And the answer key is attached to the back. Okay. All right, cone problem. Okay, set up our proportions. Radius of the small cone is to the radius of the large cone, as the height of the small cone is to the height of the large cone. Yeah, if the water is being pumped at a constant rate of 3/5 feet per hour, this is referring to dVdt, cubic feet, as volume per hour time. At what rate is the depth of the water in the tank changing? That's dHdt. But the tank is half full, so half full. So 8, halfway between 0 and 8 is 4. So we gotta be careful here. Do not use this until the end. Height is still changing. We still need to hold on to that variable. Okay, so the hint is this dHdt. we want to solve for DHDT. So if I can get my volume equation in terms of height, then DHDT will just naturally flow out of that equation. So I prefer to rewrite the equation with the R removed. If I want to remove R, I need to solve for R so that I can find a replacement for R. Okay, so I want to solve for R on page 17. Okay, so there's a substitution. Okay, and now I gotta clean this up, make sure that you're following your order of operations, right? We don't want to do pi over 3 first. We gotta clean up the parentheses first. So distribute the exponent through. So I like to get to this point. If you get to this point, you're sitting pretty well because your equation is nicely cleaned up. You're not gonna mess up with your derivative. So getting to this point is important. Yeah, any questions so far? Yeah.
And are the formulas gonna be on there? We didn't tell them.
Yes. Yeah, I'll give you the volume surface area or area of circumference. If you cone, I'll give you cylinder. Just have to make sure you know Pythagorean theorem, area of a triangle. Those are the only ones I won't give you. Okay, dVdt. Coefficient stays. Now, once you're here, now everything is free to go in. So 3/5 goes here, H goes in here, and just trying to solve for DHDT. Okay. Moving the fraction over to the other side, I can multiply by the reciprocal. Okay, make your calculator reduce. 12 over 125, but the pi stays in the denominator. That's important. Notice the location of that pi. A lot of students want to bring that pi up because it feels more natural, but that's going to change the value of your answer. Okay, units of measure? Feet per hour. Okay, questions?
I have a question on like when to use each one. For some of them, we do like 5R equals 8H, and then we just plug in R. H.
Oh, so how do you know whether to solve
How do
for
I know
R or
when?
solve for H? Okay, so I look at what I'm trying to get to. I'm trying to look for DHDT. So H will produce DHDT, but R is not going to produce DHDT, right? R will produce DRDT. So if I can get my equation in terms of H, then DHDT will naturally flow out of it.
So I just need to get H by itself. Like I need to find out.
You need to get R by itself so I can replace R in terms of H. That makes
then you
sense.
just have to-
That's right. Yeah. And the R is removed, right? If you solve for H, then you're finding a replacement for H, but we don't want that. We want to find a replacement for R. So we want to solve for R. Okay. Page 18. Go ahead and find all the derivatives. We know we're going to need them. Okay. From A to DADT, from C to DCDT. Okay, radius is increasing at a constant rate. So that's DRDT. What is the rate of increase in the area of a circle? And the circumference is 20 pi. I'm trying to solve for DADT. So let's see how much I have. I don't have R yet. I have DRDT. So I want to find what R is so I can find the answer that I'm looking for, but I'm not given R, but I'm given circumference. Is there a way for me to get to that radius? Well, this is not this. These are not the same, right? So I can't replace 20 pi in for DCT. These are not the same thing. Is there something else I can use? Yeah. What if I insert this in here? Right. If I replace C with 20 pi, I can turn around and solve for what? R. If I have R, then that's the final piece of the puzzle, right? Now this 10 can be used to help us find Ddt. Area is two-dimensional unit, meter squared. Time is seconds per person. Okay, cylinders. Number 4. Any questions so far? Okay, so cylinders, the formula looks a lot like bones, but there's no similar triangle. There's no need to replace R in terms of H. Your radius is never going to change. So your radius is a constant. You can replace that as soon as you find it. And there could also be a lot of extraneous solution. So we're not going to solve this the same way that we do with cones. Okay, cones, we do similar triangles. We do R over H equals, R over R equals H over H. Here, we don't do that. How fast is the water level rising? Looking for DHDT. When the tank is half full. Okay. Now let's think about this problem here. Water is flowing into the tank. Is the height changing? Yes. So we need to hold on to that variable. Okay, we're not going to replace that variable. Is the radius changing? It's staying the same value. So I want to find out what the radius is so that I can replace it so that I don't deal with that variable anymore. Now, I don't have the radius given to me, but is there something that can help me find the radius of this cylinder? The area of the circle is 25 pi, right? So area is pi r squared. Take that information and solve for r. This is where we want to be right before the derivative takes place. Much easier equation than cones. We don't have to deal with a variable and clean that up and make substitutions. Okay, dVdt. 25 pi stays. H becomes what? Insert 8 for dVdt, solve for dHdt, and we're at the answer. Okay, divide both sides by. Now, what trips students up here is there's some extraneous solution or extraneous information that we don't need, and a lot of students feel like they have to bring them into the problem, and so they end up doing the similar triangles because of that information. So what information do we not need for this problem? Anything dealing with the height, right? The height 16, water level is 8. It's not even needed for this problem. But because it's provided, a lot of times students feel like they have to bring it in, so they end up doing a cone problem with that information. Okay, let's go to page 14. Let's do a shadow problem. Set about proportion. Height of the small triangle is the height of the large triangle as the base of the small triangle. What's the base of the small triangle? It's not the x, right? It's the y. Over the base of the large triangle. What's the base of the large triangle? X plus 1. Okay, so careful here. Make sure that you put a y here, not an x. Cross multiply. This is the only equation that we need. Find the derivative. Time is involved here, dx dt. Okay, a man is walking away from the pole at a speed of 5 feet per second. That's dx dt. Rate of change of the person walking is dx dt. Rate of change of the shadow length is dy dt. So we can solve for dx dt and dy dt, but then it says the tip of the shadow. So tip of the shadow is just adding the two rays together, dx dt plus dy dt. Because this is the person walking either towards or away from the lamppost. And dx/dt is the rate that the person is, the distance between him and the lamppost is changing at any moment in time. And then dy/dt is going to be the length of the shadow. The length of the shadow is going to continue increasing as he walks away. Okay, this reduced to be 10/3. And so now I can find the rate of change of the tip of the shadow. Part B, find the rate of change of the large triangle. Everybody okay with part A? Area of a triangle is 1/2 base times height. Okay, what's the base? Good, x plus y. What's the height? Clean all this up. Okay, we have an area formula for the triangle. Now the ADT. What does 15/2 x become? Derivative here. Remember, time's involved here, so what does that become? 15/2 stays, x becomes d what? dx dt. 15/2 stays, y becomes dy dt. So now we have an equation, we can insert them in and find dA dt. dx dt we found from before was 5. dy dt 10/3. Okay, what's the unit of measure here? B squared. That's the area, right? Two-dimensional. Time is okay, questions? Okay, let's do a L'Hopital's rule problem here, number 6 on page 14. Okay, first thing we do with any limit problem, we always do what first? Plug in, right? And what do we get? 0%. So we have the green light to do L'Hopital's rule. Need the derivative of the top and the bottom separately. X cubed minus 1 becomes x squared. Bottom becomes 12x squared minus 1. Okay. Reevaluate. Don't find the derivative again. We reevaluate. What do we get? 3 over 3. That's a real number, so we stop. Yes, each time you get a 0 over 0, you get the green light to do L'Hopital's rule once. So if I got another 0 over 0 here, then that means I can do L'Hopital's rule again. But we don't want to just keep taking the derivative until everything turns into a constant. We got to know when to stop. Okay, number 7, linear approximation. Okay, so first create an equation with the decimal removed. And in place of it, you have an x. That's your equation. Your point is going to use the closest whole number. I'm going to insert into the original equation to get the y value. What's cube root of 8? 2. And in the denominator, so 1/2. Okay, so all of our work now is just with that information. We're going to ignore that until the end. Because I inserted 8 into the function to get the y value. That's my ordered pair. Okay, let's find the derivative so we can get to the slope. Bring this up. I'm doing two things here. I'm converting that to a rational exponent, and I bring it up to the top so I can do power rule. Bring down the exponent, subtract 1 from the exponent. The derivative can get you the slope. Point slope form. Okay, we've taken care of the linear portion of our problem. Now comes the approximation. I'm going to get that y by itself, move that 1/2 over. Now you're only plugging in the decimal. Don't ignore everything else. Okay, just the decimal. Okay, I think I've gone through every type of problem. Okay, so let me know if you have any individual questions.